Well, let me precede my comments by saying I am optimistic about the solar industry, despite the pessimism that I will be talking about for the remainder of this podcast. No, I don't think we are getting the right balance. I was recently at a conference talking about PV module failures. We're seeing failures of modules straight out of the box, like initially out of the box, failing IEC/UL requirements for visual inspection.
So solar scaled at such a breathtaking pace, but the workforce didn't. So first of all, we have a fragmented workforce, which means that these crews are usually made up of very different backgrounds without a clear pathway for workmanship or skill development. The second thing is there's a lot of underestimated skills in the workforce. So for example, crimping, a crimp looks simple, but there are so many details that go in crimping that will make or break your system.
Welcome to episode 7 of PV Unplugged, Standards, Testing and Education. This series we're talking about the burning issues facing the solar industry today. I'm your host, Jonathan Gifford. And this episode we're diving into the intersection of PV standards, real-world installation challenges and the potential training gaps that can influence system reliability. Because at the end of the day, PV is a relatively young industry and a fast-moving industry, which can bring up a whole host of challenges. My co-host today is Guido Volberg from Stäubli. He heads up product regulatory affairs at Stäubli. Guido, thank you very much for co-hosting this episode with me.
Thank you.
Now, I mentioned the speed of change within the industry. It can present challenges, and sometimes the technology can lead the evolution and the development of standards, but sometimes it's the other way around. Can you kind of set the scene a little bit of the importance of standards within the PV industry?
Yes, of course, the standards are really, really important. As you said, we are still a young business, and we are still gaining experiences now from the field. And so when I started to write the PV component standards almost 30 years ago, we did not have any experience there, and we had to use the technologies or the requirements for other technologies, and I had to check if they can be applied on the photovoltaics. Now, 30 years after that, we are gaining the experiences, and so we have to review again the requirements we created so long ago, and have to check if they are too severe or too weak.
And it's a constant process of evolution, of negotiation and development of these standards.
Yes, of course. This is... It's not only that we improve the requirements, we have to adapt also new requirements or even new standards. When we started this creation of the standards, we had the PV modules installed in small power plants and on rooftops. And today we have building integrated PV, we have floating PV, we have agri PV, we have desert PV, whatever. And so, of course, the conditions are changing, the environmental conditions are changing, and so we have to improve the existing requirements, or we even have to create new standards of that.
Okay, well, let's delve into this and also the implications for durability and reliability with our two guests today. Our guests are George Kelly, he's the secretary of the TC82 group, and Tristan Arian Lorico from PV Evolution Labs. Gentlemen, thank you very much for joining PV Unplugged today.
Thanks, Jonathan.
Happy to be here.
Okay, Guido, let's kick off the discussion.
Yeah, okay, so I just made a statement why we create so much standards or new requirements. And, one of the reasons is also that with the fast and big rise of the PV, we also detect more and more failures again and again, unfortunately. So, George, what do you think? What would you say? What is the common cause of the failures? Is it more technical, or is it lack of the standards, or is it the economical reasons such that the quality or the components are cheaper and so the quality is bad?
I think it's mainly economic pressures, not only to purchase less expensive components, but the manufacturing process. Modules are getting bigger and bigger because that's more cost effective for the factory. But then that really introduces some challenges in the installation. And I think the other pressure is time. Many of these power plants are on a very tight schedule, and so there's a lot of pressure on the construction people to do things fast and not necessarily right. And I think that's where we probably have a chance to make the biggest improvement is in training of those people who are doing the actual construction of the plant.
Yeah, that's a good point. So do you think currently the teams on site they are equipped and trained such that they can do their job in a good way?
I think they're getting better. I think a few years ago, 5 to 10 years, it was really bad. They would just pull people off the street and give them a hammer and say, "Here, make a PV plant." Now, especially for the bigger developers, the ones who understand the cost implication, you can save money when you're building it really fast and cheap, but then you're not going to get the performance and longevity that you expect out of your investment. So those kind of people are focusing a lot more on training and quality checks on the ground during construction.
But when we are now talking about failures done in the field, also from the installers, Tristan, how do you think the pressure in the industry, does the industry find the right balance between the low capex and the long-term reliability?
Well, let me precede my comments by saying I am optimistic about the solar industry, despite the pessimism that I will be talking about for the remainder of this podcast. No, I don't think we are getting the right balance. I was recently at a conference talking about PV module failures, and George just spoke about failures in the field from module installation. In our testing at Kiwa PVEL, formerly PV Evolution Labs, we're seeing failures of modules straight out of the box, and modules failing, like initially out of the box, failing the IEC/UL requirements for visual inspection. Like this isn't after stress testing. These are, we're hired as a lab to stress test the modules and see if they fail. But we're seeing an increasing number of modules that fail without us even stress testing. They're failing creepage distances, clearance distances within the module, creating electrical safety risks and frankly fire risks right out of the box. So I don't want to let the module manufacturers off the hook because they're providing the warranty and they're responsible for ensuring their products meet not only the minimum requirements, but the industry and the buyer's requirements. But that said, if you're buying modules from companies that are losing hundreds of millions of dollars a year, which is what happened in 2025 with a lot of the big manufacturers, in some cases you get what you paid for. And you can't the manufacturers are under too much economic pressure to build modules that are reliable, and that are going to last the 30, 35, 40 years that is being used in these financial models. So no, I don't think we have the right balance of economics and reliability currently. I think we can get there, but we need a quality reset in the industry.
So may I ask you, the modules you saw or detected with the failures, have they been certified?
Oh yeah, certainly. We're not a certification lab, so our testing is mainly on extended reliability testing, and we also do batch testing. So buyers, as modules are coming off the line, they're taking a pallet of modules out of 1,000 pallets and randomly selecting that and sending them up to us for random testing. And it's 61215 duration testing, thermal cycling, damp heat, potential induced degradation, UV induced degradation. These are known mechanisms, failure modes of modules. But all the modules are certified. They all have that certification mark on the data sheets and on the labels. I'd love to say we're seeing these failures in perovskite modules that aren't available yet, and they'll be available in the 2030s or something. But no, these are mass-produced modules available today that, we're not seeing they all fail, but what is the industry appetite for failures of modules right out of the box? My appetite for them is zero. Anything more than zero is too many.
And George, did you want to jump in on that also?
Yeah, I would say that the industry was there 25 years ago. We had better quality, much lower volumes, of course, and fewer manufacturers, but it can be done. And, when I was working in the module factory and running the, in-house testing like what PVEL does, we were concerned about that, and we were careful. And if we found, things like you're talking about, delamination around the edge of the laminate, we would stop the line and figure out what was happening and not ship product like that. And apparently we've lost that ethos in the industry.
Yeah, I think, George, what you were saying about bringing people off the street to install modules, it's happening in the factories too. Taking people off the street to build modules, and they have a quality control plan in these factories, but they don't necessarily know why bubbles are bad. They know, like, hey, you can't have bubbles around the perimeter of the module. But they also know that their line has to produce however many thousands of modules per shift. And, it's just a tiny bubble, it should be fine. But we know, us on this call, know that those tiny bubbles impede on the creepage distance, and now you don't have enough electrical insulation, and you're going to plug in this module in a 1500 volt string, and you can get an arc fault across that tiny bubble that the person on night shift at 3 a.m. on a Tuesday that was driving an Uber last week is like, looks fine. It's so small, So again, I'm optimistic that we'll get back there, but the amount of volumes are huge now. If George, back in your day when you were making modules, if you shipped 3% defects, it was hundreds of modules. Now, if like a 5, yeah.
When I started, we were making 4 kilowatts per week, 140 watt modules.
Wow. Sorry, I was just going to say, I was recently in a 5 gigawatt module factory, and there was modules everywhere. They're making over 9 million modules a year. And that's a lot of potential failures, even if they're at 3% defects, which, I don't know if that's their shipped defect rate or not. But just to say, the volumes are enormous, and there's multiple 5 gigawatt factories throughout the US, and there's even more in India, and let's not even get started about how many in China. You know, as an industry, we're producing, I don't know, 100 modules a second or something like that worldwide. It's a crazy amount of volume, and if yeah, that's a real struggle to make sure each one of those can last 35, 40 years.
Yeah, so now I asked you if the modules have been certified, because I also heard from situations that accredited testing and certification labs offered a certificate 3 weeks after starting the project. And the 1,000 hours DMP test, it needs 6 or 7 weeks, only this one test. And we have several long-term tests in the standards. So did you hear about that? And a question to both of you, maybe George.
Well,
did you hear about that?
I have heard that there are concerns with certain accredited labs not doing the right job. I haven't heard that one about 3 weeks for a certificate. That seems really crazy. Although, part of it is the way we've structured the standards, and especially the retesting guidelines. If I have a certified product and I change something, I don't do the full test, only certain parts of it. So it's possible that that is a legitimate test. If I changed the screw in the corner of the frame or something, I probably don't have to do the full damp heat and thermal cycle test, and that's possible. But I think people are definitely abusing it and taking shortcuts to skip tests.
And why would that be the case? Tristan, do you have any idea? George mentioned, first of all, time is a factor, right? Speed. People are rushing.
Yeah.
They want to get their projects built and stuff shipped.
It's a fast-moving industry. There's a lot of policy changes that impact what bill of material you want to use. So, changing your location for cell production. This is more for modules going into the US, but there's a new tariff case and you can no longer buy cells from Indonesia. So you're going to buy cells from the Philippines, but you have a project that's ongoing that was expecting to use those cells from Indonesia. Now you want to use the new cells from the Philippines, and you don't want them to sit in a climate chamber for 7 weeks to get certified. You hire the lab that happens to have the climate chamber / time machine device, and now they can get you a certificate in 3 weeks instead of 3 months. The whole reason for Kiwa PVEL being set up, and before we were part of Kiwa PVEL, historically, we were never a certification lab. We're there because of the shortcomings of certification, and realizing 15 years ago that modules that were certified, they were all certified, they all performed differently in the testing that our founders were doing as developers in their lab as IPPs. They set up a lab to better understand how to buy modules. All of them were certified. All of them had 25-year warranties, but they were seeing field failures on some and not others, and they wanted to better understand that. So they set up their own lab for the company, and then realized, wow, we got the industry can use this. And so we were set up to address some of the shortcomings of certification. And, a bigger risk I see is that a lot of module manufacturers are now self-certifying. So the certification body will certify the manufacturer's lab to basically do their own testing and write their own certificates on their own products. So this isn't as critical as Boeing self-certifying the MAX 8 jets, but still, I think it presents a conflict of interest. Manufacturers are under a great deal of price pressure, a great deal of pressure to change materials, and if they're able to certify their own modules in their own lab, no wonder you need people like PVEL to to qualify those modules as part of batch testing to make sure the buyers are getting what they pay for.
Yeah. So Tristan, what do you think? Which risks does this create for the developers or the asset owners if they get certified modules which do not comply with the standards?
Well, then it's a very difficult situation for them because it costs a lot of money to replace a module, and modules. Well, it probably doesn't cost a lot of money to replace one module. It costs a lot of money to replace hundreds or thousands or even hundreds of thousands of modules. So, I think it puts the developers, the asset owners in a difficult position of potentially having an underperforming asset that just stays underperforming. If something is a safety risk, they'll need to replace it. But if something has higher amounts of degradation than expected, you need a tremendous amount of degradation to justify the cost of replacing those modules. You might get replacement modules for free if you get a successful warranty claim, and that itself is a big if. But replacing the modules, the labor for that is on the asset owner. And so you need a large amount of underperformance to get an ROI on that replacement. If it's just underperforming by 5 or 10%, there's no financial case to replace those modules, and instead you just have an underperforming asset. We're trying to avoid those as an industry. We want this industry all players in the industry to be making a profit, modules and systems to be performing to specifications, manufacturers making a profit on the modules they sell, so they're not incentivized to cut corners. And that's where we can have a mature and long-term industry. But I don't think we're there today.
Well, I think there's often a bit of a narrative, that testing, that certification and standards is sometimes lagging developments in the industry, not moving at a sufficiently fast pace. But actually, in terms of the move towards higher voltages, Guido, it's a bit of a different dynamic. What can you tell me about the move towards 2,000 volts and then higher from a standards perspective?
Yeah, you're right. It's now a little bit different. Usually, in the industry, first of all, the products are developed, and then the manufacturer create a standard. In the standardization committees, usually manufacturers are creating the documents. But now for the 3,000 volt, I think it is because we are leaving the low voltage limit. And this is really brand new, and we are making big steps into a new world. And so now, finally, we now started last year to develop standards for modules having 3,000 volt or for 3,000 volt system voltage, and also the component standards. But we still need a lot of work to create the PV array standard, the inverter standard, and so on. It's not only modules and connectors which are used in a system.
Yeah, and George, bringing in you on this, I think the move towards 1,500 volts, that actually happened very quickly in the industry. So the race will be on for standards to be in place for the move to higher voltages. What are the implications, George?
Well, I think it's not uncommon for the industry to be ahead of where the standards are. That's what happens when you're innovating and bringing new products to market. In the case of the 1,500 to higher voltage, that has been a really big jump. I mean, you mentioned that we went quickly to 1,500. but that was because there was a standard that said this is a limit. You follow low voltage rules up to 1500. Once you go above that, you have to make new rules, and that's what Guido was referring to. We have been discussing this, planning for it for maybe 4 or 5 years, and actually started writing the documents last year. And there's still a lot of concern and pushback from other technical committees. The people who are in charge of fuses or relays, they have concerns about going to these higher voltages that, probably a normal glass to glass PV module can withstand 3000 volts if it's properly built, if it doesn't have bubbles around the edge like Tristan was saying. But there are lots of other things in the system that are highly affected by that voltage.
And Tristan, as a quality assurance provider, how challenging do you think this transition to higher voltages will be?
I think on the module side, it's going to be challenging, mainly because we're going to take it for granted and just say, okay, with larger creepage distances, everything will be fine. And with the perfect module, it can be 2000 volts or 3000 volts. But we're not making the perfect modules, sadly, and in mass production 100% of the time. Some of them, sure, are perfect, but we're not doing it 100% of the time. And, we're still seeing PID, potential induced degradation issues that were discovered on like 600 volt systems. They got worse on 1000 volt. They got worse on 1500. We're still seeing PID as an issue. Like, we have not retired that test as an industry. And this is just more potential, higher voltage, higher potential means we're going to start causing new failure modes and new PID things right as we're introducing perovskite modules and new cell technologies. And again, they might be okay on small scale samples, but are they okay on a 1500 or 2000 or 3000 volt structure? That makes me concerned. And as an industry, we often release products and new modules and then realize, oh, these have an issue. And we've got a long history of that. LETID, UVID, probably even further, LID. I imagine back in George's days when they were making 120 watt modules and realizing they degraded 3% in the first year. That was like a huge finding. And then we solved that over time, but we created LETID in the process. And then we solved that with N-type, but we created UVID. We're currently solving UVID. We're not there yet, but we're going to create something else. And I think going to 2000 volt or higher is going to introduce new failure mechanisms that we don't know about. And with the size of the industry, we'll figure them out once we have like 100 gigawatts of affected modules installed. And even if the standards is trying to get ahead of it, all of these unknowns come back to bite the industry.
Yeah, but of course, this is a challenge, but I think we have to go this way. Yeah, this is a challenge. We also thought about this when we increased the voltage from 600 volt to 1000 and to 1500 volt. But yesterday we had a kickoff meeting at Fraunhofer ISE for research power plant for 3000 volt. And I think we are getting some experiences also from these researching projects. And in the end, we are doing this to save money, to decrease the number of inverters, of string inverters, and reduce the cables. Higher voltage is less current, and so on and so on. So I'm pretty sure it will work in the end.
And it's always the double-edged sword, right? New technology brings with it new risks, but it also brings lower production costs. The volume that has made solar what it is today. And also, this is deployment and decarbonization, which is the big goal at the end of the day. I think at that, we've come to time. It's a fast-moving industry, and we have to move on with this episode of PV Unplugged. So thank you very much to my co-host, Guido Volberg, Product Regulatory Affairs at Stäubli, and our guests, George Kelly, the Secretary of TC82, and Tristan Arion Larico from Kiwa PVL, who's always a ray of sunshine. And coming up, we'll have Andrea Kobsch, Program Specialist, Business Development at Stäubli, and we'll look into the role of testing and training in the PV industry and how that can help enhance durability. She'll be joined by Katrin Theis from Green Vesting, so stick around for that.
Thanks, Jonathan.
Yeah, thanks for having us.
Welcome back to episode 7 of PV Unplugged, Standards, Testing and Education, where we're talking about the burning issues facing solar today. I'm Jonathan Gifford, your host. Even PV components with the highest quality can be installed incorrectly. And it's often the small details that make a very big difference. In this episode, we're looking at how training can be effectively rolled out and what impact it can have. My co-host today is Andrea Kobsch, the Program Specialist Business Development with Stäubli. Andrea, welcome to PV Unplugged.
Thank you, Jonathan.
Now, you work pretty much day in, day out with industry training. What are the challenges that you face in kind of delivering the training that the industry needs, that practitioners needs, really at scale that the industry needs?
Yeah, so you mentioned something interesting, scale, right? And delivery. So solar scaled at such a breathtaking pace, but the workforce didn't. And I would say that standards are also having a hard time catching up. So the big challenge of delivery can be kind of explained with 3 fundamental or structural issues. So first of all, we have a fragmented workforce, which means that these crews are usually made up of very different backgrounds without a clear pathway for workmanship or skill development. So there's not really a clear path for them to see, okay, this is what I have to do now in order to get this skill jotted down. The second thing is there's a lot of underestimated skills in the workforce. So for example, crimping, a crimp looks simple, but there are so many details that go in crimping that will make or break your system. So, people are not thinking about, is my crimp airtight? Or when they're torquing, they're not thinking, did I reach 7.3 Newton meter torque force? So these are very detailed nuances of the training, of the installation that people don't really have in the back of their minds. And last but not least, compatibility. Compatibility is a big issue, right? So, and there's also this issue of cross-mating. We see it constantly, even in mature markets like Germany. So, we need to fill those gaps. And the beauty about training is that training makes standards a habit. So once you have your workforce trained, they just, they have these skills and they do it every day to the point where it's bulletproof. So that's where we want to get. And yeah, training and education is definitely the catalyst for this.
Yeah, the catalyst. And also, we've heard in previous episodes how time is also a factor, right? Nobody really ever has enough time when they're on site, when they're planning, and also when you're delivering training to the industry at the scale that's required. Okay, some big challenges, but also big payoffs if done correctly. Let's hear how it works in practice. Our guest is Katrin Theis, who leads technical management with solar crowdfunding and installation company. They're also providers of O&M, Green Vesting. Katrin, thanks so much for joining PV Unplugged.
Thanks for being here.
And from your perspective, how does on-site training influence your capabilities and also your business?
Yeah. Well, in my opinion, it really boosts our capabilities and strengthens the business. Being trained directly on site helps us understand challenges faster and try out solutions right away. And honestly, like open-minded people benefits the most. In my point of view, they are the ones who make the biggest gains from new ideas. And I think these kind of co-workers bring knowledge on site to the building teams, especially if you have people who are not really educated. You have one person who brings the knowledge to them. And if they are open-minded, it works, of course, a lot better.
Yeah, that's an interesting perspective. So training's also a two-way street, right? It's not only the challenge and the way it's delivered, but it's also the openness from the person who's receiving the training as well. Andrea?
Yeah, so because it's my day-to-day thing, I want to know, Katrin, what does effective training look like to you?
That's a great question. I like that. I feel like many people still don't realize how important ongoing training really is. For me, there are 2 points of view. The best setup is a mix. Like project managers can get everything they need through online training because their work is more about planning and the processes. But the building teams really need on-site training, hands-on in the real environment with the right standards and maybe also country-specific requirements. That's where the learning actually sticks when I'm out in the field.
And so when I'm designing training, I have to be very mindful of the people who are consuming the training. So I would love to ask you, what insight do installers bring to, let's say, the training and education world that standard committees and that manufacturers don't?
So the installers bring the practical, so the real life perspective that is often missing from standards and manufacturing teams. Like the committee focus on the regulation and framework, and also the manufacturer focus on product functionality and design. But the installers, however, work directly with the materials in the field. So they have to encounter on-site constraints like local practices and safety challenges that aren't always reflected in theoretical standards. Their feedback helps to ensure that products and standards are not only technically correct, but also visibly efficient and really important, safe to implement in the real world conditions.
Yeah. What do you think is the biggest misconception that, engineers, developers have about what really happens on site?
Yeah, I would say that a lot of engineers and developers don't fully realize what the actual situation on site looks like. For example, things like weather, tight spaces, or rough conditions have a huge impact on how work gets done. And installers don't always have perfect tools available either, which is sad, but it is the way it is. So even a well-designed product can be hard to install if the real world conditions aren't considered. For example, I had a brand new PV plant just built up, and I recognized lower energy output in one string. So I went there, and when I looked into the issue, and I was shocked to see that they had used the inside of MC4 connectors in the new Evo connectors. Didn't even think about that these are two different products and that there's no connections between there's a connection, of course, between MC4 and Evo, but if the inside of the connector is wrong, the connection is not like it should be, and the result is, of course, lower energy output and even then other things.
And you mentioned something interesting because, the MC4 family of connectors is intermatable and interoperable. But just because it clicks doesn't mean that we did it right. So, and that happens, imagine, even within our family of connectors. And then if we add that uncertainty of bringing a third-party manufacturer where, we cannot guarantee that the interaction between plastics is going to be as we have tested it. So, that is a very good point. Just because it clicks doesn't mean it's going to work. I guess you mentioned something that I really liked, and it is that for standard committees, it is important to hear what the installers have to say. How do you think that feedback can be integrated into the standard committee discussion?
Yeah, that's it's really important. And this point of view I would describe as it's really very important to take installers' feedback into account. The best way is to build, for example, simple, consistent ways for them to share what they see on site. Yeah, and things like quick feedback tools, pilot projects, or even inviting a few installers into early discussions. When their real-world experience is included, the standards become much more practical and I think also more accepted, which also means that the training is more accepted, less difficulties, less issues which doesn't work, and also like the crossover problem which you mentioned before.
Yeah, from my side, that's super interesting to hear how impactful that kind of feedback loop can be, because the installers, they're the ones in the field, they're the ones on the roof, often in all types of weather, so facing these challenges day to day in real life. So wonderful to share that experience. Thank you very much. I'm also fascinated. I was also fascinated to hear how, cross connectors or incompatible connectors can instantly make a significant impact on power output. And you can see that on the string level, remotely monitoring it immediately. I wasn't aware that would have such an immediate impact at a solar array. Well, thank you very much for sharing your insights, Katrin Theis, who leads technical management with solar crowdfunding and installation company Green Vesting. Thank you for joining PV Unplugged today. And thank you also to my co-host today, Andrea Kobsch, Program Specialist Business Development at Stäubli. Thanks for joining PV Unplugged, and also our previous co-host on this episode, Guido Volberg, Product Regulatory Affairs from Stäubli, and his guest, or our guest, George Kelly, Secretary of TC82, and Tristan Arion Lorico from PV Evolution Labs. And that's the last of our live episodes in this series of PV Unplugged. Coming up will be a recap episode where we revisit, reflect on, and unpack some of the highlights, some of the issues that we explored throughout this series and over the past few weeks. My name's Jonathan Gifford. It's been great to have your company again today on PV Unplugged.